you've shown what that variance is, that X naught transpose times X transpose X inverse, where these big X's represent the design matrix. This little X naught represents the vector for our prediction, times X naught times sigma squared. That's going to be our variance. And so if we want to turn that into a standard error, then we just take the square root of it. And so to calculate a confidence interval around this mean response, it's going to be just this y hat 0 plus or minus t star. So that t star is going to be just like we would get otherwise from like a t distribution that we would use with n minus p plus 1 degrees of freedom at whatever alpha level we're interested in, times the square root of our variance, which is going to be equivalent to sigma hat times the square root of X naught transpose times X transpose X inverse times X naught. So that's going to be the confidence interval for the mean response. Okay, now let's talk about a prediction of a future value. So in this example, this is an example something like, suppose you want to feed your chicken sunflowers. What will your chicken's predicted weight be? And so now the prediction is slightly different because we're predicting a future response. The prediction is going to be X transpose, or X naught transpose. So this is that same vector of X values for the individual of interest times beta plus epsilon. So we have this error term here because we're predicting a future response. And so now we need to think about what the expected value of this is and what the variance of this is. And so that's what I want you to do in this next part of the application exercise. First, I want you to calculate the expected value of X naught transpose times beta plus epsilon. And keep in mind that we know the expectation of beta. We know that this X transpose naught is fixed, and we also know the expectation of our error term epsilon based on just our linear regression theory. So go ahead and calculate what that expected value is. And then I want you to take the variance of this thing that you just calculated an expected value for, and I need you to show that it's this quantity right here. So it's going to be 1 plus X naught transpose times X transpose X inverse times X naught, that whole quantity times sigma squared. So once you've shown the expected value of this, I want you to then calculate the variance, and this is the final answer that you should come to. And so show all of those steps in your application exercise, and of course we'll walk through them in the next class.